presentation. This will be a very introductory presentation towards high school audience only. To give you guys a little details about myself, my name is Jenny Zhang. I am the president of the 5113 Combustible Elements Robotics team, currently a junior at Morristown High School, and I do a lot of research with AI and creativity on the side, outside of robotics and schoolwork.
And I'm Vlad Mondar. I'm also a junior at Morristown High School, and I'm the systems engineer design lead of the Combustible Lemons. And I'm also a programming and chemistry nerd. You can find me on Chief Delphi. That's my ad.
So to give you guys a little background about myself, when I started FRC freshman year, I had no idea how to code. I had no idea how to do literally everything in the program. I started from scratch because I got dragged in by a friend. I fell in love with it. I did a research project on my side, a couple of different research projects, and then I had the pleasure of interning with Comcast last summer, which is the first internship where I worked with the public speaker you saw in the morning, Jason, in the AI and discovery team. This is just a QR code because this slide is very long. There's a lot of good resources. If you want to take the QR code, it gives you access to everything on the slideshow. So if you want to look back on it, if you want to take a look, share it with more of your friends that didn't make the meeting, feel free. I'm just going to leave this up for 3 more seconds. 3, 2, 1. Okay.
And at some point when I present, there's also going to be sources provided for a lot of the things that I say. Hopefully it's helpful. I don't know if it is.
All right. To give you an outline of what you're going to gain out of this 15-minute session, so obviously we're going to introduce yourself about what AI is. I feel like everyone has a pretty good extensive knowledge on that. I'm just going to go over some of the jargon, some of the basics of artificial intelligence, machine learning, et cetera, et cetera. And I'm going to talk about a bit about how you as a high school students can tap into this new industry. Vlad here will explain to you guys how some of the FRC applications of artificial intelligence will look like and how you can get better at it. And at the end, I included some opportunities where you can improve or utilize these skills. So, raise your hand if you have used ChatGPT in school before. Yep. This is definitely a very substantial number to look at, especially towards the younger audience. More and more people are starting to look at the utilization of artificial intelligence in our everyday life. So artificial intelligence, in my opinion, can be broken down into pattern, imitation, and decision. And as this famous quote said, it's not a threat to humanity. You will not take over the human world. It's only an extension of our minds. So the way I like to think about artificial intelligence is think of how you learned multiplication when you were in elementary school. Did you just automatically knew how to multiply 2 by 3? No, you memorized this, in my opinion, my enemy of my elementary school year, the multiplication tables. How you learn is you're given a pattern, and in our human minds, we try to imitate this pattern until we can make decisions ourselves. Or if we're given A and 6, we can come up with the conclusion that it's 40A after giving enough training and practices to this kind of model. So some skills that you should probably obtain before you want to dive into the wide world of artificial intelligence is that you should really look into picking up the programming language. Personally, I threw Java and Python there. I really personally prefer Python. It's my personal favorite. It makes everything simpler. It's used a lot wider, and a lot of the newer applications, libraries for machine learning and artificial intelligence are more oriented towards Python. I really recommend looking on online resources. There's a ton of online courses and online resources, which I will talk more about out there you can learn. There's a lot of programming libraries, also more details later on, just so you can look at these different libraries. It's really useful to get familiar with them, not just for machine learning, artificial intelligence in general, but practice using them. Math level, at least Algebra 2, make sure you can do algebra. I feel like it's basics. There are some calculus concepts sometimes gets thrown around in machine learning. It's not necessary because when I started, I personally wasn't familiar with calculus. it's useful to get familiar with the different concepts of calculus in order to understand algorithms better. So this is an overview. Artificial intelligence, I like to think of computers doing the job of human. Artificial, fake intelligence, brain capability. So we just basically have a computer that imitates the brain capabilities of human mind. Machine learning is subcategories of artificial intelligence. Computer learns from these set of data you give to it. You give the material for it to learn, and they can use what they learned from the past in order to implement it towards newer data sets and draw connections from them. Deep learning, machine learning model that learns through multiple layers of neural network. Again, more details later on. If you look at the next slide, it gives you a pretty good performance of what deep learning do to normal machine learning models. Deep learning is utilized a lot in things like natural language processing, which the most familiar model will be ChatGPT to you, and image recognition. So a list of AI jargons you hear a lot thrown around in the artificial intelligence world. Neural network, if you know what a neuron is, human brain cell. It's inspired by human brain cell. It's layers and layers of nodes. They're basically like human brain cells that picks up information, pieces pattern together, and recognize different language pattern or image patterns for the artificial intelligence model to make a decision. Algorithms, I feel like if you're into computer science, you should be really, really familiar with the world, or step-by-step instructions you give to the computer to tell it what to do. Usually it's in the form of code. Data processing is fine-tuning the data to be used to train the model, to give to the model, and so the results can be accurate, because depending on what you train it based on, like if you give an elementary school a math book and an English book, they will learn two different skill sets. Training, again, going along with data processing. It's in order for your algorithm to work, you really need to separate your data into different sets. What I usually like to do is that I use 0.2 like subsets of my data into training the model, and then use the rest to prove that the model actually works. Overfitting and underfitting is talking about how much data you're giving into the computer algorithm. So if you're giving it too much data, it can make predictions that are too precise, where if you're giving it too little data, it can give you a very vague line that doesn't really tell you anything. Natural language processing, we all know what it is. ChatGPT, it takes in our everyday speech, our different speech patterns, jargons, whatever we use in our everyday speech, to transform it into things that the computer actually understands to make a decision in its response. So, can someone raise their hand and answer these three questions for me? The color, shape, and texture of this orange. Well, hold that thought. Can you move to that side? What about this one? So these two are very two close things. So when you have criteria that are defined this loosely, you would think that how would a computer know what's the difference between those carrots, maybe, towards orange? So this is a neural network. Really, this is the simplest neural network model you'll probably ever find. Is that what happens in a machine learning model is that the computer takes in these different sort of information, like, for example, the traits of the orange and the carrots. But these very basic traits gets formed into hidden and deep different layers. In the middle, you see the hidden layers. There are layers that form patterns into recognize these oranges and carrots. So, for example, the carrots had leaves on top of them. The orange only had a tiny stem. Maybe that's a pattern that the computer will be able to formulate from the different set of input they're gaining. And the output layer is the ultimate results you're getting. So all these input layer and the hidden layer gets formed into the results you want based on the different assigned values that are going through these layers you're adding into. The closest value, or the higher the value is, usually it's the more closest to the goal that you want to obtain. This is the data training model. This is a very simplistic graph of what I was talking about with overfitting and underfitting. To underfit a graph, you can see that because that too little data were given, the line becomes very linear, where usually these patterns are a curve, or where there's a general trend, but usually in everyday life, trends are never strictly linear downwards. And whereas in the overfitting section, you will see that because that you fit so much data into the computer algorithm gets a little too precise with its results, and they will want to form a very precise result. So when you're telling them that orange plus yellow is red, they wouldn't take in the range of orange or range of yellow. They will only think of that specific shade of orange and specific shade of yellow comes to the shade of red. So how can you get started with artificial intelligence as a high schooler? Again, you really need a foundation for this if you didn't have it. School courses, recommendation, a lot of them are on there. And on the second bullet point, I included some online resources. Khan Academy, completely free. Stulos Academy is where you can gain your credits outside of school. Dual enrollments at local colleges are also very valuable options. There's a lot of school courses that can help you, but what I've learned in general is that these courses are excellent at giving you bulk of information, but how you actually learn through coding is that you have to repeatedly try and do independent projects by yourself in order to improve your skills. Coding-wise, CS50 on edX is a really amazing course. It's completely free. You should definitely look into it. There's also online resources, Discord servers that can help you out if you had any questions in the course. GitHub, very obvious. If you had experience in coding, GitHub is a very open source coding directory that a lot of programmers share their codes, and you can ask others for advice or look into different machine learning models that other people built. YouTube, the most directly one. There are a lot of resources which I will not be listing. If you simply look up artificial intelligence introduction, I'm sure you'll find hundreds of videos on this topic alone. And although I included a list of libraries, I only included Python because that's the language I'm most familiar with. NumPy, Pandas, Skitlearns, TensorFlow are very useful libraries for you to learn. If you master these basic libraries, you're able to directly off the bat to build very simple machine learning models and practice your skills. Now, what's after you build this foundation? Empty slide, because in my opinion, there's nothing you can learn other than going independently on your own to further develop your resources and your skills. Sure, you can find internship, research opportunities, and I get that in the high school world that a lot of people tend to get very competitive because younger and younger generation are tapping into this industry, but it really doesn't matter how late you start. Like last summer when I was working on the internship, a lot of people on the AI and discovery team didn't really tap into machine learning and artificial intelligence until they were in their 30s and 40s, and they're working at Comcast. They're doing pretty well off. You really have to work on yourself and work on independent projects. It helps for you to join a robotics team, to use it in a real life situation, but it's a very self-studious thing that you have to continue to work on.
So you have a general idea of what AI is now. So how can you use it in terms of, FRC? And I will say that, in terms of using AI on robots, this is a frontier. Neither I nor you nor I would assume most of you have worked, in the audience, have worked with AI tools on, real robots. And I do also steal a bit of Krypton Cougar's thunder in terms of their presentation that they did this morning on vision, because yeah, well, so there's 3 use cases that I could immediately think of in terms of AI use on robots. Well, on a robot, not necessarily on a robot, but we'll get to me complaining about that later. So, no, that's. I apologize. So, object detection is, pretty obviously the thing that we're looking for here. Objects don't have April tags on them, so like you can't. There's no traditional way to say this is a cube this is a cone and this is a cube. Like you have to specifically come up with a way where like to figure it out, because like you could. This goes to the core of AI application, where like it's like with the carrots and orange, where how do you know which one's a carrot and which one's an orange? Well, like you can start to list parameters, but at the end of the day, there's no real correct answer that will generalize beyond just like letting the machine do it. And then object tracking is a derivative of object detection, where you just like this is more of a stopgap solution than like anything practical, because the specific application we'll see is tracking the amount of objects in an indexer. Well, limit switches exist, and they're pretty good. Like a limit switch does not tell you, oh, there's probably I'm pressing against an object probably 80%, as you would with AI. A limit switch is, yes, there is definitely an object here. With AI, it's a bit more complicated, but it's certainly more generalizable, where like as a limit switch, you have to think, okay, I want this limit switch here. And then you can detect certain objects, but if it goes on the other side of your intake, well, you can't detect it anymore. Then double counts and stuff like that. This will probably give you the right answer most of the time. And for scouting, it might be useful, but we'll get to that. So I know that this is an introductory presentation, and the basics of AI, like the fundamental level, is wildly complex. Like you made a generalization, and it's good as a beginning, but in terms of application, without even looking at the fundamentals of how it works, there's 4 steps to like practically using an AI. Well, practically applying an AI. Well, the first one is you have to find a data set. Like if you look back at the X's and O's example, where you're trying to classify the X's and the O's, well, you have to have those X's and the O's in the first place to know what you're doing. And I will admit that this is probably the hardest step, because 99% of the time it's a poor human that has to go and find the examples of what is a cone and what is a cube and what is an April tag, kinda, and put it together in a way that you can actually use. And the second is, the second and third are, if you want to make your own model, you can ignore this step and go right ahead with creating a model. But what? Well, no. You can the training your own model is nowadays, at least, to make it do anything useful is difficult, because you need an entire data set, and you also need a bunch of resources, which, well, I don't have, and you don't have too. So we can rely on the generous work of the people of the internet to get our basic models which then we can fine tune to our use cases. Do you think that a model that's trained on humans, dogs, and cats knows what a cube and a cone is? Well, in terms of like FRC terminology, no, it does not, because cones and cubes, in terms of like FRC cones and cubes, are not a daily occurrence for most of us. Well, most of the people in the world. For us, I don't know. I see them regularly on Chief Delphi. Anyway, and then, no, go back. Sorry. And then so you have your model. You have like the numbers that compose the inner and outer layers of your neural net. Well, what good are they if they're on your computer? They have to be on the robot. And that's a lot more difficult than you would think. Yeah. So I'll go over the basic steps of how you would do this. And like this is already like this part has been done and it's generally worked through. You can, if you just want to get started with classifying cones and cubes, well, there's already models out there that have been fine-tuned, but this is how you would go about doing it. So in this case, you have your video frame. This is something you'd expect from a regular match. This one's specifically taken from the good work of Team 900, Marshall specifically, but this comes from the kickoff video where you have, a cube and a cone, and some April tags too, where there's nothing specifying in that image, oh, that's a cone and that's a cube. What you have to do is you have to create a bounding box around them, just like drawing it out here, like that, with a specific name. So in this case, there's the cone specified in terms of where on the screen it's located. And after you've done that a sufficient number of times, because, got to get all the edge cases, you have to find a model. Well, you don't have to look far. Generally, researchers are apt at publishing their models, and this is actually, after you finish your general education in AI, this is what you do. You create models. Oh, duh. But in this case, we're going to use a specific type of model. It's called YOLO. And it's an acronym for You Only Look Once, which, and models generally have a purpose. So for this model, the purpose is be fast and also precise, because otherwise it's not useful. So this is a graph of a certain version of this model, which, as you can see, outperforms the speed of a different model, which is slower. And this model is general purpose. It can detect cats and dogs and humans and cars and etc. It's deployed in the real world, but we want it to detect certain FRC objects. So here's a screen from the Infinite Recharge game, the one in 2020 and 2021, where you're looking for power cells. And after training, you would get that this is a power cell and this is a power cell. Well, obviously it is a power cell, but the computer doesn't know that, and it can only know that once you've trained it. It's a bit redundant. And it's also not certain of the fact that this is a power cell. And that's the other important thing about AI, is it's all non-deterministic, where AI, could you be sure that those carrots in the beginning slide were oranges or other way around? No, you can't be. But you have to do it anyway. So there's this value just means I'm 60% or 67% certain that's a power cell, which is probably good enough that it's labeled. You can see that this cutoff of a power cell is not necessarily labeled. It's not a power cell to begin with. Next slide. And then you hit the ultimate issue of, okay, I have my model and I can find power cells. How do I use it? Because, so this is a Tesla T100. This is your general data center computer where you can, you plug it into a big desktop or a server if you're in a data center, and it does calculations very, very well. But then you have to apply it to you still have to do those calculations to get a robot. For your robot to be able to detect power cells, you still have to do calculations. They're obviously less intensive than the ones used to train it, but they're still there. And just for funsies, I did the napkin math for putting a T100 on a robot, and assuming a power consumption of 750 watt hours, which is fairly normal for a computer, powerful one that is, it will eat about 25% of your battery. Is that good? No. Considering motors already eat like more battery than you have, 25% is not good. And also, next slide. Next slide. Next. What? Wait, is this actually? Okay, there we go. So, to there, like, the flimsy PCIe port on a Tesla GPU is not going to survive that. So we have to come up with other things that are less power hungry as well. So, and here, this is another divide where, like, if you want to start out doing vision, limelights are a very good choice. But, and even modern limelights based on Raspberry Pis with a Coral can do AI pretty well. But there's a broad range of things you can apply to get to your final result of being able to detect things, from, well, your simple Raspberry Pi, on which a limelight is based, to a mini computer, to a NVIDIA Jetson, which is a considerably smaller version of a Tesla. And as you will see, detecting things or anything in FRC is a trade-off, and here is as well. So the broad specifics here don't matter. There's a great resource by Anand. Both his coprocessor and camera roundups provide great details that are very useful when you're trying to make the trade-off of cost, efficiency, performance, and usability. Next slide. And camera choice also matters. Where I'm just putting this out here. This is something that I've worked on personally, so I think it's important. But like on a limelight, you have the camera that you get. There's no changing it. But in terms of making your own setup, which you'll probably end up doing with object detection, not certainly. Limelights and Corals work very well. But if you want to, it's certainly interesting to work with different components. My personal favorite is this camera. It's it looks something like this, but it's a 90 FPS global shutter chroma camera. It's perfect for the thing it's designed for, which is to detect April tags. So choose your knife well. And, well, there's always the limelight. The most recent edition based on a Pi 4 is really good at detecting things, especially if you're just getting started on working with it. And you can go to the next slide. There's a, what do you mean video can't be loaded? We tried this. It was fix it. This is a video clip from Behind the Bumpers about Town Robotics' robot, which I've clipped out to include the part where they spoke about their detection system, which is based on. You can just. I don't know. Whatever. I'll show the video later. And obviously there's always the do-it-yourself option, which is photon vision. And I will note that photon vision currently, as it is, does not support artificial or AI networks. There's a PR 928. If you're a programmer, you can go to Photon Vision, github.com/photonvision/photonvision/ pull request /928, and it's common knowledge. And you'll see that there's progress being worked on it. And if you're a programmer, I highly encourage anyone can contribute to this, and it's certainly pretty interesting to try. And there's always build-it-yourself options using OpenCV and other technologies. And what do I have after this? And obviously there's scouting, where it's a mixed bag. Well, so the opening talk today talked about, like, there's a metric you're trying to reach. And with, in terms of detecting things, there's obviously a metric, like, does it see the thing? Yes or no? And it's a bit more than binary, but with scouting it's even more difficult, where we will try our greatest invention of this era, FRC GPT, to answer this very, very pressing question, where the ultimate answer is just garbage. It's not useful. I've summarized it in one sentence to save your time. And the other thing is Statbotics, my favorite website because statistics. It also doesn't necessarily use AI. Well, I guess in a way it does. Fake intelligence, we say. And it uses linear algebra, a concept commonly used in AI, and very useful in terms of calculating statistics. And I personally don't know what the future will hold in terms of AI application. Finding hidden trends, video analysis. It's difficult to say, but I'm kind of hopeful it'll be good. And
all right, to close off this presentation, I would just like to talk about a few opportunities you can do as a high schooler to get better at artificial intelligence in general. This is not specified to FRC. One is research and learning program. The program I listed here, I'm not affiliated with them. I've done them in the past. It's my personal recommendation. Inspirited AI is a Stanford and MIT alumni program. What they do really good is that they have different programs based on how skilled you are at coding, and they have a really wide range of different learning programs and one-on-one research program that helps you develop your own research paper. Independent research, I really recommend Polygons, is that you can have a research topic in mind, you can have your ideas together, and Polygons, what it does is that they assign you to a mentor that really helps you formulate everything together to get it presentable before an audience that's a lot older and more knowledgeable than you. Internship, look for internship positions at local companies. Cold emailing also worked really well for, personally for some of my friends. I know that, they emailed renowned companies in New York and got internship and featured in newspapers, which is insane to think about, but you don't know it unless you try. It's just you have to be constantly on the lookout for places to actually practice these skills you learned into programs and projects. Self-study, GitHub, Reddit, and many other online resources and forums proves to be really good support for learning. Try starting a small independent project like Bob mentioned, build your own simpler models and just mess around with them really until you can further develop it into something more complicated. Also, a couple things I'd like to talk about that I forgot to mention. Raspberry Pi is a very useful thing to have around and practice your coding skill with. Should consider picking one up, and as Bob mentioned, it could be used for AI and robotics. And AI doesn't have to be just coding. My internship last year was with the software developer and product managers. Like Jason mentioned this morning, product management really is the bridge between business and engineering. If you're not into all the jargon of coding and stuff, you can still be in this new field, but working slightly off the technology branch. Or you can do, for research, you don't have to do computer analysis-based research. You can do literature reviews of what currently exists in the research field and find out what further research needs to be done and This is incredibly helpful for other researchers, and there are many famous researchers that are known for their literature review on this newer field. That's it for our presentation. Feel free to reach out to us if you have any questions. We're both very open to answer any questions, and if you have any questions right now, feel free to ask us. If you have a more technical question, I suggest you ask this guy.
I will also happily debate you on almost any topic related to FRC, so please contact me.
So is it going to be a water contest?
If it will, I will be very happy, so I don't expect it.
We don't have to get rid of a lot of our stuff. It's not waterproof.
Yeah, that would be hard. And I guess we'll answer questions as well. And if I could go more in depth into FRC applications.
Does anyone have any other questions?
I do. So for the combustible lemon, did you use any AI on your robot last year?
Well, no. The only reason why I'm comfortable even suggesting building your own setup is because we did in terms of April tags, and we achieved fairly decent results. On the software side, yes. On the hardware side, not so much.
We had a bit of miscommunication. I don't always know everything for that was supposed to be.
And I really want to try it out this year. It's a lot of the development, say, why? It's not frozen. Yeah, there we go. Yeah, the YouTube. I'll open that. But like this development is very recent. This is not even stable software. It's just it's a prototype of what the technology that many teams are already using can be extended to include like AI applications.
It's a really good FRC project if like teams want to just keep it on the side and develop this object detection, because you see like a lot of similar game pieces being repeated years after year, and if you know the process of how to set this up, you'll build it much more successfully during an actual build season.
I'll try to load the video now. I don't know why it's so incredibly unhappy with me. I guess.
Did you share your screen or your?
It's showing the tab right now.
There we go. I solved the problem.
We'll show a little bit on screen here in a second, and then kind of just work your way through anything else you want to cover. So the object detection is powered by the Google Coral, which is a co-processor, and so
I guess the quality is not very good.
So,
I'll play it, I guess.
Here's our Limelight. So this is just a Google Coral plugged into the Limelight, and then this is on the detector pipeline. And we basically just use to upload a model that the Limelight provided. And so right here we could see the object detection, and we use object detection and auto to pick up our last cone, because we realized like after moving throughout the field in auto, our position, especially like going to get that last cone, our position is sometimes off, and we need that to be perfect in order to grab it perfectly centered with the cone. So we use object detection to make sure that we line up perfectly with the cone in order to score it center.
Any other questions?
So that was the video on
1323, yeah. Yes, the explanation I remember is the last, like, after so many movements, your precision isn't precise enough in terms of your localization on the field to get the last cone, like, consistently. Any other questions?
For our presentation. Thank you very much for coming.
Okay. I think that I think we have about 10 minutes left in this section, so free time.
Why not? So, to my knowledge, all artificial intelligence are built on human activity. It's only going to transform with human intelligence. I mean, I don't really think that there's going to be aliens for it to draw samples from. So for now, I don't think it'll take over humanity.
Well, like the state of the art in AI now. Well, my answer to that is the state of the art in AI now is copy humans, and until they figure out what natural selection is, I think we're safe. Question?
Okay. What if we build a self-aware AI? So like an AI that is self-aware, but like can mimic the actions of humans. Some humans are horrible. What if they copy the actions of some humans that are not very looked happily upon?
I mean, why would we
develop a nuclear bomb?
What engineers like to do building these projects is that they set certain restraints and constraints. So I don't think an engineer is stupid enough to do something like that. I mean, personally, I would think that they would be persecuted pretty heavily by the government.
In my understanding, if you train AI to build a nuclear bomb, it can tell you how to build a nuclear bomb, but it lacks hands, so it will not build a nuclear bomb.
Does anybody have any questions about interning at